Okay, so our notes are going to be on parabolas, and the first thing I want you to change in the objective is we're going to write and graph the equations of a parabola given, can you cross out foci and put focus? There's just one focus in a parabola, the directrix and a vertex. And secondly, we're going to find the vertex, comma, focus, and directrix of a parabola and graph it. We've talked about simplistic features of parabolas, like them facing up and down. We're going to be more specific here. We're going to talk about what a focus and a directrix are. So the first thing I'm going to do is you have on your paper a little picture that shows what a parabola looks like. So this one on your paper is a blue parabola and it's facing upwards. And what there is with a parabola is there's 2 points that are new. We know what the vertex is. The vertex is going to be right here. The focus is what one of the new points is. So a focus is going to be a point that's within the parabola. And what's also new is a line called the directrix. And that line is going to look like, for this problem, it's going to be a horizontal line going across. What is special about the focus and the directrix that allow me to come up with the equation or the graph of a parabola is the distances. You can see it kind of drawn nicely on your paper. The distance from the focus to a point on the parabola, whatever that distance is, I'll make it 1 hash mark, it would be the same distance from that point to the directrix. So no matter what point I pick, if I pick a point on the parabola over here, the distance from that point to the focus, I'll make it 2 hash marks, is going to be the same from that point to the directrix. And that's where you come up with the set of all points that are equidistant, because they're in the middle. It's kind of halfway through between the focus and the directrix. So the first formula we need to know is x minus h squared equals 4p y minus k. H and K are going to stand for your vertex, and we know the vertex is kind of the middle of the graph. It's the minimum or maximum, and it would go through the axis of symmetry. What's new is this distance from the vertex to the focus. We've not talked about P before, but all P stands for is the distance from the vertex to the focus, and you can get that just by looking at your graph or counting. Now, we're going to use this x minus h squared formula when my graphs are going to be facing up or down. All right, so if I have an x squared graph that's going to go up or down, that's when I know I'm going to use equation 1. Okay, to be more specific, to find out which way it's going, on your paper you have it drawn out for you. You're going to use x minus h squared equals 4p y minus k. If p is greater than 0, so let me kind of go with black here. On your paper it says if p is greater than 0, right? And p greater than 0 meaning p is positive. Your parabola, if p is greater than 0, is going to be facing upward. So on your paper you have an upwards facing parabola. You have your vertex that's on the parabola. You have the focus that's within the parabola, because your focus always has to be on the inside of your parabola. And then you have, drawn in red, you have the directrix. And that directrix is equidistant from the vertex to the focus. Whatever that distance is, it's the same distance from the vertex to the directrix. So here's your directrix. And because this directrix is a horizontal line, it's always going to be named a y equals. And we'll get to how you name those later. Besides, if my parabola is a smiley, my parabola could also be a frowny. The way it would be a frowny would be if my p-value is less than 0 or negative. If that p-value or that distance is negative and I'm facing downwards, my parabola is going to be a frowny. My vertex is going to be the center of the graph, or the middle, kind of maximum of that. My focus would be within the parabola, and then my directrix, let me kind of go back to red, whatever this distance is from vertex to focus, that same distance in the opposite direction, this is going to be my y equals directrix line. Okay? Now, if you shift down to equation 2, it's very similar, but if you see, you'll see y squared. This is going to come first. So this is x squared is 4p with a y. This one's y squared. Y squareds are going to be when my parabolas are opening up to the right or they're opening up to the left. All right, so if it's left or right, it's going to be a y squared. My h and k still stands for my vertex, and the p still stands from the distance from the vertex to the focus. So in order to figure out which way you're drawing your parabola, you have to look at the p-value. If my p-value is greater than 0, then what I'm going to do is I'm going to draw with a y squared. I'm going to open up my parabola to the right. My vertex would still be the middle part of the graph. My focus has to be within the parabola, so there's my point, my focus, and then my directrix, again, I'll do that in red, will be whatever this distance is from vertex to focus, it would be the same distance in the opposite direction. And it's going to be where it's not going to ever intersect your parabola. So you'd be like, well, why don't I go horizontally? Your directrix has to be basically parallel, in line with the vertex and the focus. It cannot cross, it cannot intersect with your vertex. And because it's a vertical line, this is going to be an x equals directrix. That's how I name my directrix. Then I'm going to draw if my p is less than 0. So if my p value is less than 0, which means it's negative. Well, if my p is less than 0 and I have a y squared, right, and that's what you're going to really be looking for in your problem, then I would have my parabola opening up to the left. My vertex is still the middle of the graph. My focus is within the graph. It's a point within the graph. And then my directrix is going to be on the other side of the vertex. So the vertex is always in the middle. It's going to be a vertical line, so it's x equals when I'm talking about y squareds. All right, so let's use this information. Let's go ahead and try to graph what we're given and then write the equation. So let's see, I'm in blue. Let's go ahead and plot what they're giving me first, and I think that gives you a great idea, and it's a much better help if you plot it first and then do your equation. So I'm going to go to 0, 2 and put a dot, and I'm going to put F for focus, and then y equals -2. I'm going to graph that in. Now, I know it doesn't look like a lot of information, but that's giving me a lot of information because I know my vertex is exactly in between the focus and the directrix. So if I draw this in, I'm just going to draw it in black. If I count, there's 1, 2, 3, 4 units away. Halfway in between would be right here at 0, 0, and I've determined where my vertex is. I also know my focus has to be within my parabola, so I know that my parabola has to be facing upwards for 2 reasons. The focus has to be within it, and I can't cross over that directrix. So once I graph it, the first thing I do is say, okay, am I picking equation 1 or am I picking equation 2? Well, since my graph is facing upwards, I'm doing the x minus h squared. So I'm going to kind of write that down first. X minus h squared equals 4p y minus k. Now, my h and my k, let's talk about that. My h and my k are going to be my vertex. Well, if I look over here, my vertex was 0, 0, and then my p-value is going to be the distance from the vertex to the focus. And if you count, it's just 1, 2. It's this distance from here to here. I'm going to kind of highlight this. Can I highlight? Yeah. From here to here, okay, is going to be 2. So if that is 2, that means my p-value is 2. So I'm going to say if my p-value is 2, let's use this information and plug it into my equation. Well, when I see the h, I'm going to plug in a 0. When I see the p, I'm plugging in a 2. And then when I see the k, I'm plugging in a 0. And that's pretty good, but I don't want to leave it like that. I want to simplify. X minus 0 squared is just x squared. 4 times 2 is 8, and y minus 0 is y. So there's the equation of the parabola with that given focus and directrix. So let's do the same thing. We've got a focus and we've got a directrix. So I'm going to go ahead and draw in the point 4, -1. I'm sorry, 4, -1, and put an F for focus. And then I'm going to go to y is 1, 2, 3. I know y equals line is horizontal. So because I know what my directrix and my focus are, and I know this is y equals 3, I need to find my vertex, which is going to be equidistant from those 2 points. So I'm going to go back to black. If I look here, I'm going to say 1, 2, 3, 4. That's 4 units away. So if I go 2 units away, this is going to have to be my vertex. So this point here is going to be my vertex. And let me write down the coordinates. It's going to be 4, 1. All right. I then know if my vertex is in between the focus and directrix, and the focus always has to be within the parabola, then my parabola is going to be facing downwards. Well, that's also helpful because if I know it's facing downwards, I say, okay, is it equation 1 or equation 2? Well, since it's downwards, it's going to be the x minus h squared equals 4p y minus k. I'm going to go ahead and plug in and say, okay, my vertex, my h and k is 4, 1, right? And my p-value is equal to, now we got to be careful here, my p-value is the distance from my vertex to my focus. And if you look, it is 2, but because it's going down, my p-value is going to be -2. So it's really you got to be really careful that if you're going up or right, you're positive, or down and left, you're negative. So if I'm going to go ahead and plug in my equation, knowing my vertex is 4, 1, and my p-value is -2, I'm going to say x minus 4 squared equals 4 times my p, y minus 1. And I'm just going to clean that up by doing x minus 4 squared is -8, y minus 1, and leave that. Okay, don't do anything to that, just leave that. That will be the equation that I have. Okay, now before we talk about x squareds and negatives, this is an x squared graph and it's a negative. So that means it's facing downwards, which is exactly what we graphed. All right, so let's try the next two. Let's draw in our focus and our directrix and see what happens. If I draw in -3, 0, and put a focus, and then I go to x equals 3, and be careful, x equals 3 is going to be a vertical line. So I draw in my directrix of x equals 3, and from there I know and say, hey, I know my focus is always within the parabola. I know my focus and my directrix in between is going to be my vertex. So if I went 3 this way and 3 this way, that's a total of 6, so halfway in between is going to be at 0, 0. I also know that my focus has to be within the parabola. I think about the parabola kind of eating up the focus, so it's got to be facing this direction, and I cannot cross that directrix. That's a huge help. Knowing that it opens up to the left, I know I'm on equation 2. I know it's a y squared, so I'm going to go ahead and say it's y minus k squared equals 4p x minus h. All right. Let's write down our vertex being 0, 0. So I know my vertex is, I'm going to put it over here, 0, 0. And my p-value is the distance from the vertex to the focus. Now be careful when you do your p-value here. I'm going to do this in red. When I count over 1, 2, 3, I'm going left. And if I'm going left, my p-value is going to be negative. So my p-value is going to be -3. So let's use these two pieces of information and plug it into my equation. So I'm going to go back to black, y minus, now my k value, be careful, h is your x coordinate, k is your y coordinate. This one's not too bad because it's 0, 0, but be careful that you're plugging in k, which is the y value next to the y coordinate. So y minus 0 squared is 4, my p value is -3, x minus 0. If I clean that up, it's going to be y squared is -12x, and that would be the equation of that parabola. All right. The last one, we have a vertex at 0, 0 and a focus of 6, 0. So let's go ahead and put in my vertex is here at 0, 0, and then they have a focus of 6, 0. Now be careful, 6, 0 is not this way, 6, 0 is to the side. That's going to mess up your whole parabola. 1, 2, 3, 4, 5, 6. So here's my focus here at 6, 0. Okay, knowing that my focus is within my vertex, I have a couple things that I can do. I know automatically that my graph has to be facing this direction because my vertex is going to be my focus is going to be within my vertex. I also can determine what my directrix is. The directrix is the same units away that the vertex is from the focus, but the opposite direction. So let me kind of go in red a minute. If I know from here to here is 6 units, then I know from here to here, like 6 units in this direction, is going to be where my directrix is. So if I count over 1, 2, 3, 4, 5, 6, if I put in my directrix, let me put it in black, it's going to be a vertical line, and it would be x equals -6 because it's going 6 units in the opposite direction. All right. Because my graph faces to the right, I know I have to use the y minus k squared equals 4p x minus h equation. I know my vertex is 0, 0, and my p-value is the distance from vertex to focus. And if you count from vertex to focus, it's going to be 6. So let's plug in. The 0, 0s are going to go away. So you might be able to quickly say, hey, if my k is 0, and h is 0, I'm just going to be left with like my y squared max. So if I clean that up, I'm going to get 24x, and my answer is y squared is 24x. All right, so second part, which is part C, we're going to find the vertex, focus, and directrix, and then we're going to graph the parabola. Now, what I want you to do immediately is kind of make a little bubble here. We want to first solve for the squared term, because it's going to make it a lot easier for us using the equations that I just went over with you if we have the squared term by itself. So when you have number 1 and it says x equals 1/2 y squared, I want to get the squared term by itself. So the first thing I would do is just multiply both sides by 2. So I have 2x equals y squared. I'm going to go ahead and just rewrite that. So it's y squared equals 2x. And there's a lot of information given to me just with that equation. All right. If we think about the other equation, the y minus k squared, like our general formula, 4p x minus h. This y squared equals 2x came from that equation. So I have to say, okay, let me work backwards now. I need to find out my vertex and my p-value, my focus, and my directrix from what they're giving me. Well, the first thing I want you to do is if it's a y squared graph, right, you know that it's going to be facing left or it's going to be facing to the right. And what I want you to do is say, hey, if it's a positive, okay, if you look on the other side of your paper, if my p is greater than 0, it's going to be facing to the right. So since my p-value is just 2, I know that my graph's going to be facing this way. All right, but obviously I need to find out where it starts. Well, my h and k are going to be my vertex. Since I am not subtracting anything from the y or anything from the x, my vertex I know is going to be 0, 0. All right, but in order to find the focus and directrix, I need to find the p-value. So again, if you remember, here was my original equation. I'm working backwards. Somehow, from this equation, 4p gave me that number 2. Right? 4p gave me that number 2. So the way I usually figure this out and say, hey, 4p in this equation, in my general equation, became the number 2. So what would my p-value be in order to make that work? Well, if I solve for p and I just divide by 4, I'm going to get p is 1/2. So I've just determined that the p-value is 1/2. That is the distance from the vertex to the focus. So let me go ahead and draw in my vertex. Here's my vertex. Now I know it's very small, but my focus is going to be 1/2 units away. Now just be careful. You're like, well, where do I put it? 1/2 where? This is where you need to remember that, hey, if it's a y squared and this is positive, my graph's going to be opening up to the right. So I know my graph has to be going this way somehow. All right, but what I need to do is, let me actually just go ahead and draw that in. I know my graph's going to have to look like this. And what I'm going to do is go 1/2 units away from the vertex. So that's just 1/2 away here. That's going to be my focus. So the coordinates for that focus would be 1/2, 0. Well, to find my directrix, I go to my vertex and go 1/2 in the opposite direction. So 1/2 would be negative 1/2 here. It's going to be a vertical line, and so it's going to be named x equals negative 1/2. So my vertex was 0, 0. I'm going to kind of just circle what I want you guys to be knowing. My vertex is 0, whoops, go to green. My vertex is 0, 0. My directrix, what do I want to find? Focus and directrix. My focus is 1/2, 0, and my directrix is x equals negative 1/2. You need to make sure those three things are labeled or pointed out on your answer. All right, so let's try number 2. Y equals negative 1/4 x squared. The first thing you guys need to do is make sure you solve for the squared term. So I'm going to multiply by negative 4 on both sides. So this cancels. I get negative 4y equals x squared. And again, I like my square term on the left, so I'm just going to rearrange that. When I see x squared, I know I'm either up or down. Because this is negative, I know that I'm going to have a downward facing graph. All right, so that's a good start. The second thing I need to know after I know it's facing downwards is find the vertex. Well, since there's no number subtracted, if I have the equation x minus h squared equals 4p y minus k, there would be a number here or here if my vertex wasn't 0, 0. Since there isn't a number, I know my vertex is 0, 0. All right, so if I put in my vertex of 0, 0, and I know my graph is facing down, I've got a really good start, but I've got to find out where that focus and directrix are. The focus and the directrix are going to be determined by the p-value. Again, if I have an equation of x squared equals negative 4y, this 4 times some number gave me negative 4. All right, I got a negative 4 by doing 4 times some number. So if I do 4p is equal to negative 4, well, my p has to be equal to negative 1. And that's super helpful because that's telling me that, hey, my p-value is negative 1, meaning the distance from the vertex to the focus. My focus is going to be right here at, I probably shouldn't do it that way, hold on. I'll not put that extra line in there. So my graph again, let me just erase the whole thing and make it a little bit neater. if I draw in my parabola, I'm at 0, 0, right? My graph is downwards. This is my vertex. My focus is going to be right here. It's going to be -1 units away. -1 would mean it's going down. And I also know it has to be going down because the focus has to be within the parabola. So I'm going to put a focus right here of 0. So let's see, let's label it over here. Focus is going to be 0, -1. And then my directrix has to be 1 in the opposite direction. So I know that it has to be 1 away from my vertex. So I'm going to be up at, up at 1 on my x-axis, but I'm going to name that because it is a horizontal line as y equals 1. So my vertex is 0, 0. My focus is 0, -1. And then my directrix is y equals 1. All right. We've got one more. If you want to give it a shot on your own, go ahead. I'll do this one with you. We want to get the y squared or whatever term by itself. So I'm going to start by multiplying by -8, and I would get y squared is -8x. The first step that I would do is determine which way it's facing. If it's y squared and it's negative, I know y squareds are either left or right. Because it's a negative, it's going to be opening up to the left, meaning my graph's going to look something like this. All right, so I've got to start with my vertex. Since nothing is subtracted, I know my vertex is 0, 0. So I'm already going to put in my vertex here being 0, 0, and I know it's facing this direction. Okay, I've got to find out the focus and directrix. The way I do that is 4p got me -8. Right, 4p got me -8. So to find my p-value, if I just divide by 4, that's going to give me the distance from the vertex to the focus. So here's my vertex. My focus has to be -2. Well, -2 is going to be left 2. So I'm going to put here. So here's my focus. So my focus coordinates would be what? -2, 0. And then my directrix would be 2 away in the opposite direction. This has got to be a vertical line, so it's going to be named x equals 2. All right, so we're going to work on a lot of these problems in class. So if you need any more help, just go back and listen to it again. Once we do examples, it will get a lot easier.